Here's problem 1125. A force F is applied to a cylindrical roll of paper of radius r and mass m by pulling on the paper as shown. The acceleration of the center of mass of the roll of paper when it rolls without slipping is... Alright, so we're applying a force at the top of this cylinder, and let's calculate the torque about the contact point at the bottom of the cylinder. Let's call it point P, which happens to be a distance 2r away. So if r is the radius of the cylinder, this whole distance is 2r. So the torque at point P will be equal to the moment arm, which is 2 times the radius times the force F, sine 9 degrees between the two. So that just be 2RF. Now the moment of inertia of this cylinder about point P is going to equal the moment of inertia about the center of mass plus md squared by the parallel axis theorem, and d is the distance that we moved from the center of mass. So this is going to be 1/2 mr squared plus m times the distance we moved, which is r, to the edge of the cylinder, that squared. So this is going to be 3/2 mr squared. And the reason we calculated that is because our net torque, which is the moment of inertia times the angular acceleration, should equal the torque about point P, because that's our only torque. Hence, we have that 3/2 mr squared times the angular acceleration is equal to 2 times r, actually in this case, times F, and the r's cancel out, at least one of the r's cancel out. Let's go back. So we have that the acceleration, angular acceleration, is 4F over 3 mr. Nice to know. That's the angular acceleration for the whole disk about point P. But we want to find the linear acceleration, the acceleration of the center of mass, the linear acceleration at the center of mass. Well, that distance from the pivot point to the center of mass is the radius of the cylinder, r, and hence the linear acceleration at the center of mass would be equal to the angular acceleration of the whole disk times the distance to that point, which is r. So that's going to be equal to 4F over 3 mr times r. R's cancel out, and we get that our linear acceleration is 4 times F over 3m. So that is the linear acceleration of the center of mass of this disk about its pivot point, 4F over 3m, as it rolls without slipping.